So now that we've learned a bunch about searching NIEM and how to find things, now we haven't looked at everything you can look for when you're finding things in NIEM, but some of that's going to need to wait until you understand the concepts that you need to look for. So we'll do that when we get to those concepts, and we're right about to start to actually do that. So to start, let's take a look at just understanding how NIEM objects work in general, how they fit together, and how we can find out how they're put together above and beyond what the tools show us to understand what the schemas are doing. So we already saw in the little schema in a nutshell section that XML schema uses elements and uses types to define things. An element is of a certain type, and what type the element is of tells us what that element can hold. So I like to say it, what you are defines what you can hold. What you are defines what you can hold. Your type is what you are. So whenever I want to know what an object can hold, I look at that object's type, and the type will tell me what the object can hold. Now the reason we do that, because you don't have to in XML schema, you can just make elements of data types, but the reason we do that is so that we can reuse the types, so that I can have multiple elements that are all of the same type. If they're all structured the same and they all have the same kind of things, but they can all have different names without replicating all the type information. So it's basically object-oriented. It's an object-oriented data model. Now here is a big diagram of person, person name, and person living indicator. Person name and person living indicator just being two of the things that a person holds. But how do we know that? Well, we have this diagram, tells us that, but we also have schema that tells us, and we're going to look at the schema for each piece to get a feel for how these things fit together. Now I could just go to SSGT, or I could go to Wayfair, and I could find out how these things are put together. But it's really important to understand how they fit with the XML schema as well. So up at the top we have a person object, and the dotted lines are the typing. So person is a person type. Now how do we know what that holds? Well, we know what it holds by looking at person type, and then person type is of object type. We haven't talked much about object type. I'll tell you right now, all it is an empty container. It's just an empty container to start with. That's not entirely true. There are some attributes added to that container that provide some infrastructure support. But that infrastructure support is a later topic, so we'll get into it when we get into it. Right now, just think of it as an empty container. Start with an empty container, make a special version of it called person type, and that will tell us what a person can hold. So if we look down at the schema, we'll see that. We've got schema defining person type. It has a definition and a type. And here's what that type looks like. So here's its type, person type. We're defining the name of the type. It's got documentation, so it's got a definition that tells us the definition of that type. It's complex content. Now we saw complex content earlier in that little snippet of XML schema. This is very, very similar. If that was just a simplified version of this. That means it holds other things. So things of person type hold other objects instead of holding a string or a number or something like that. It's based on object type. Now we haven't learned much about object type, but we just learned that it's an empty container. So this is an empty container. It's not based on anything, any existing sort of thing. And what does it add? Well, it adds a bunch of things. Now, if you've got sharp eyes and a good memory, you notice this is the start of the list in Wayfair when we look at person, and the start of the list in SSGT when we look for person. So things of person type can have a person accent text. They can have a person age description text. Then there's a comment. This is an XML comment here. And there's a whole lot of things. You saw the whole list, right? You saw the whole list when we looked in SSGT. You saw the whole list in Wayfair. I had to remove some of them just to get it on the screen. But every time I show you schema, pretty much from this point on, unless we're making something new, it's directly out of NIEM. This is literally copy and pasted out of the NIEM schemas, put into these materials, and all I've really done is commented out some of the extra elements just so that we can get everything on the screen. If you go down further though, you get to person living indicator. Cool, things of person type can hold a person living indicator. How many can they hold? 0 to unbounded. And this is typical of almost everything in NIEM. Almost everything in NIEM has cardinality of 0 to unbounded. There are a few exceptions that you will run into, but for the most part, NIEM treats these objects as pieces that you can put together in the way you want. NIEM isn't going to tell you how many person living indicators a person should have. Kind of makes sense that there would only be one. But here's the problem. If we say that, then we got to look at every element and decide cardinality for every element and hope that we get it all right. Basically, NIEM kicks the can down the road. Because if you're using person living indicator in your message, you probably have a better idea what the cardinality should be than the people making NIEM. So NIEM leaves it 0 to unbounded to give you the ability to set those however you want in your actual message specification. After person living indicator, whole bunch of elements that got removed for clarity, and then hey, person name. Cool, now we know things of person type can hold a person living indicator and a person name. And then a couple more at the end, person home contact information and person augmentation point. We don't know what a person augmentation point is, but that's something we will learn later in the training, but this is the end of the list. So I gave you the start of the list, the end of the list, and a couple of things in the middle that are particularly pertinent to our diagram. And then if we go down a little further, we see the element declaration. So here's an element called person of person type. So persons of person type, here's a definite person type. We know that things of person type can hold a lot of things, but among them, a person living indicator and a person name. So we'll scroll back up to the diagram. And now we know the beginning. We know the beginning of the diagram. We know why the person can contain a person living indicator, because we just looked it up in the schema. We know why a person can contain a person name, because we looked it up in the schema, and the definition of person type told us all that. All right, let's go look at person name next. So person name contains a given name, a middle name, and a surname. And each of these are of a person name text type, which is derived from a proper name text type, which is derived from a text type, which is derived from a string. How do we know that? How do we know all that? Well, we got to look at the schemas, so we'll scroll down to that part of the schemas. So here are the schemas out of NIEM defining a person name. So first off, we see here's a type, complex type, things of person name type contain things, other objects. They don't contain strings, they contain objects. Based on object type, now we know that this is just an empty container. So this isn't a special version of something already existing, it's just an empty container. And it has a bunch of things. Now they actually fit on the screen, so I put them all in. Person prefix abstract, here's the given name, here's the middle name, here's the surname. Again, the cardinality is 0 to unbounded. That's typical for NIEM stuff. And then there's other things. Name suffix text, maiden name, full name. You need the full name. That's the whole name as a string, because some systems can't handle having the name pieces. I know it seems a little strange, but it's true. Some places really just have names as full single strings. So we need to support that in NIEM as well, and a few other things, a given name, official given names, preferred names, effective dates, things like that. And here's that person name comments text as an attribute. So this tells us that a person name contains all these things, including the given, the middle, and the surname. So that's how we know the top part. That's the top part of the graph. That's how we know person name contains a given name, a middle name, and a surname. But what do those contain? Well, you need to look a little further. We'll scroll down to the types. And now you're starting to see why we like to use the tools, right? Jumping around the schemas is not a lot of fun. But before we get to those, I forgot to mention, then we have the person name element of the person name type. So that gives us the top part of the diagram. We go a little further, we get to the stuff about person name. So let's just deal with the typing first. Let's go down. Actually, let's go down first. Let's look at given name. All three of them are set up the same. So we'll look at given name first. It's a person name text type. So how do I know what that means? How do I know what that contains? Well, part of it is a given here. If it ends in text type, it means it's a string. Okay? A lot of things in NIEM, they tell you what kind of things they hold, data types, tell you what kind of things they hold right there in the name. If it ends in the word net text, then it's going to hold text. Makes sense. But how do we know that? Well, let's go look at the type. Person name text type. It's extending something called proper name text type, and it adds a person name initial indicator to tell us whether that name is an initial or not. I call this the Harry S. Truman attribute. Harry S. Truman, you know what the S stands for? Nothing. It's S. Harry S. Truman's middle name is S. It's not an abbreviation. It's not an initial. It's actually S. My understanding of the story is that there were two relatives that both wanted to have their name be his middle name, and his parents said, well, we'll just split the difference. Both their names started with S, so we'll just make his middle name S and they'll both be happy. But it's not an initial, it's actually S. So you could use this indicator to tell the difference between an initial and not. So that gets applied to person names. It doesn't matter in other contexts, so it's applied to the person name text type. But what's the proper name text type about? Well, here's proper name text type, and all there is to it is derived from text type. Once upon a time, there were probably things in here. I'd have to go back and look at earlier versions of NIEM, which again you can do. If you want to see more about this and see what it used to be, you can go look it up in an early version of NIEM in the SSGT. SSGT goes all the way back to NIEM 1.0. Nowadays, though, it's just an extra layer that just hasn't been removed. And that's of text type. That extends text type. Well, what is text type about? Well, if we go look at text type, we find that that's a string. That's a string. It's a built-in data type provided by XML schema itself, although we wrap it in a little wrapper called NIEM-XS. And this adds some infrastructure attributes. Now, I've mentioned infrastructure attributes earlier, talking about the object type. Yeah, the object type that's just an empty container but actually has some infrastructure attributes to it. This adds those infrastructure attributes to a string, the NIEM-XS. And we'll learn about those when we get to them. But it also adds a partial indicator to say if this string is a partial string, truncation indicator to say if the string has been truncated, and a language attribute that comes from XML schema that lets us say what language a particular string is in. And so these things all get added. So now I know something of given name, a given name element is a person name text type. It can have that initial indicator, but also have the two indicators shown here, the partial and the truncation, and can have a lang attribute to say what the language is. And I know all that because it's a person named text type and this fairly long derivation chain of types that tell me that. So now we're back to the diagram, and now we know all about the given name, the middle name, and the surname, and we know there are of all these types, and we know that it's eventually of string, and we know that things that end in text type are strings. We name the stuff appropriately to give you a hint as to what kind of type it is. That leaves one last one, and that leaves the living indicator. Now, indicator is another one of those things. It's what's called a representation term, and it represents a kind of data. In NIEM, indicator represents a Boolean, and we can tell that for sure by just looking at its type and finding out its type is Boolean. Now, let's go look at the schema. That part's short. So that is the shortest part of this little schema demonstration. Here's person living indicator. Its type is Boolean, and it's wrapped in this little NIEM-XS again to put infrastructure attributes on. Eventually you'll find out those attributes, but that's a more advanced topic we'll get to later, just so you know they're coming. So there, now we know everything we need to know about that diagram and how things fit together. And if we take all that information together, it all defines an instance document that looks like this. It's a person element. By looking at person, we can tell person's a person type. Looking at person type, we can see that a person can contain a person living indicator, and it can contain a person name. So that's how we know. By looking at person living indicator in the schema, we see that it's a Boolean, so we know it can contain a value like false. By looking at person name and looking at its type, person name type, we find out it can have this attribute, and it can have a given name, and a middle name, one or more, and a zero or more, and a surname. And then that's the whole instance document. Now, if you're wondering who Peter Deaf Breeden Whimsy is, he's a fictional detective. There's actually a link in the materials, goes to Wikipedia. He's a fictional protagonist in a series of detective novels and short stories long ago, 17th century. So he's gone, he's dead. Everybody who wrote his stories are dead. They're all dead. So we're going to use him as our example for no particular reason other than he does have two middle names, so that's handy. But you'll see Peter as the example throughout the materials. He's the example we're going to use. He is the crash driver. So, what I know from evaluations of these training materials and doing the training live for people is that about 1/3 of the people looking at these materials are JSON developers. The other 2/3 are XML, but 1/3 are JSON. So, how do you do JSON? How do you do NIEM in JSON? Well, the answer is not easily. It's not easily. We're not in a good spot for JSON support right now at the moment of this taping, recording. At the moment of this recording, we're not in a real good spot with JSON. You can do JSON in NIEM, but what you do is essentially mirror the instance document that would match some XML schema that you built from NIEM. So we use JSON LD for that because JSON LD gives us some special attributes to do some things. We're going to look at one of them here, and the other one later when we get to infrastructure. Again, I keep promising infrastructure, but it is coming. So the first one we use is this context attribute. And what this context attribute does in JSON LD, the LD stands for linked data. In case you're wondering what the LD stands for, it's a superset of JSON. It's JSON with some extra power added to it. But the context is a mapping function. And all it really says here is that anything starting with NC is from here, from NIEM core. So that's the actual name for NIEM core. We're going to talk about namespaces, and you'll learn more about this then. But just know for right now that this context section is a mapping. And it says, hey, anything with an NC prefix is really NIEM. So you know what this is because it's the same as a NIEM core person. It's right out of NIEM. And you know what this is? This person name, this maps to the person name in NIEM. So it provides a mapping up front before you actually have the JSON that represents the data as part of the exchange. So this is kind of a front, this is like front material metadata about the data to come. But so we use this out of JSON LD. There are some other means to shorten long NIEM names into more amenable JSON names. It's called normalization. Outside the scope of this training, but there's a whole document about it. If you want to know more about it, you can go to the training materials on GitHub. Remember, this whole document is on GitHub. I can learn about it there, but it's outside the scope of the training. We're not going to talk more about it here. Note that the structure of the JSON mirrors the structure of the XML. So here we've got a person with a living indicator and a person name inside of it. That's exactly the same as the XML. It's the same structure. You have to keep the same structure. You end up with JSON that essentially mirrors the XML. That's what you get. And that's where we are with JSON right now. JSON LD and JSON schema are two different things. JSON LD is about linking data with JSON. JSON schema is similar to XML schema. JSON schema defines what a JSON document should look like. But we don't have support for JSON schema in NIEM at this moment. Efforts are underway. By the end of this year, 2022, we should be in a much better place regarding JSON schema support with NIEM, but we're not there yet. So right now, JSON with NIEM is simply making JSON instance documents that match the XML document that would validate against the NIEM schemas. And it's unfortunate that that's where we are. I wish we had better support for JSON right now, but we don't. But a year from now, we should have much better support for JSON, including JSON schema, including support in the tools. Throughout the training, I'll show you matching JSON instances. Whenever we do an XML instance, I'll show you the matching JSON one so you can see how they look. Just keep in mind there is no underlying JSON schema to validate that against. So that gets us to our first bit of mapping. So what should we start with? Well, what we're going to do as we go through each step, we're going to revisit this UML diagram, and we are going to highlight the things we're going to tackle in that section. And then after we do them, we'll cross them out. We'll literally cross them out in this diagram. And then by the end of the mapping, everything will have been highlighted, dealt with, and crossed out. And we'll have everything mapped to NIEM, and then we will have the equivalent of that complex UML diagram in the form of our mapping spreadsheet. But this is the first step. Let's do something easy. Well, what do we already know a lot about? Well, we already know a lot about person name, and the surname, the given name's middle name and surname. We already know a lot about that. Let's do that one first. So, some things are easy to find in NIEM. Things like a person. You search for person is what comes up. You search for person name is what comes up. You search for person given name is what comes up. Yeah, I can kick off searches for these. Let's kick off an SSGT search. And there it is. It's the first thing that came up right there automatically. It's just, and a lot of things are easy like that. And same for Wayfair. You search on Wayfair, hey, came up with person. It's exactly what we wanted. And you'll find the majority of things will match like that, especially generic concepts, especially things like people, organizations, locations, activities, very generic type ideas. They're going to map very easily. You're going to search for them. You're just going to find them. We could go look through the schemas for them, but we literally just looked at the schemas for them. So we're not going to look at them again. You've just seen the schemas. We did the mapping is really easy. We've opened up person. We saw the person name. We opened up person given name. I mean, we open up person name inside the given name inside of that. We've already seen that in detail. So what do we get in terms of artifacts out of that? How do we mark our progress? Well, first thing I like to do is keep track of my text document. This is where I'm going to keep track of the structure, the elements I'm going to use, and how they're going to fit together in the eventual instance document. So I've got a person name indented one level, and a person given name, middle name, and surname indented a level from that. The little plus signs in the left column there, that is simply to tell you which lines have been added, because this is really just a text file. It's just a plain text file. So we'll just mark I can't format it differently, it's just a text file. Let's put a plus sign in the new elements so we can see the new stuff that had been added in each stage. And let's look at our mapping spreadsheet. So here is the mapping spreadsheet for it. And what I'm going to do in this spreadsheet is I'm going to mark the new stuff in blue. So every time we add stuff to the mapping, we're going to mark it in blue so we can see it. Because eventually this is going to be full of mappings, and it'll be nice to be able to tell. So we had a person here, a person class in the UML, and it maps to NC:person. The NC is NIEM core. The name of the element is person. Very easy match. We've got person name, person given, person middle, and person surname as well. But look, we had to add a line. We added a line here. This line 5. Whoops. Why did we add line 5? Well, we added line 5 because in the UML, we just had first, middle, and last name inside a person. Why? Because that's how people naturally think of it. If you ask somebody the structure of a person in their name, very, very few people are going to say, well, there's a person, and inside there is a person name, and inside the person name is a given middle and surname. No, they're going to say a person has a first, middle, and last name. So NIEM breaks that down for the sake of reuse, for the sake of having building blocks that you can use to build other things. But you're rarely, if ever, going to see people structuring their initial business UML as NIEM. If they did, you'd get that complex NIEM as a complex UML instead of the simple UML that we're actually working off of. So we need to add a line for the person name and put that in here. Now remember I said I was going to underscore frequently the fact that you need to understand the structures in the objects. And here is our very first case of that. You cannot just map person to person, person given name to person first name to person given name, person middle name to person middle name, and last name to person surname, and say you're done. You can't do that. You need to have the structure. You need to have the person name in between to provide that structure. You need to understand what the person object looks like and how it's built up. This is not a flat data dictionary. This is a model, and different things hold other things, and you need to take that into account as you're building and as you're mapping. So you will need to keep that in mind, and you will need to add lines to your spreadsheet for those structural pieces. So I needed to add a line to the database, not to the database, to the mapping spreadsheet for the person name object itself. Now, if I were doing this for real, as a real project, I would put person here, and I would put person name here, just to keep everything done, everything filled in on the left. Also lets me, if I want, I can resort by class if I want. I'm not going to do that in training though for a good reason. I want you to see as we add additional lines for the mapping, the left side you'll be able to see the stuff we've added to take into account NIEM structure. And I think that's important to understand and see the extent to which that happens. So when we add new lines for things to take into account how NIEM does stuff, you will see that in the form of blank lines on the left. Because we need to add a lot of structure to take into account how NIEM is structured. So we did that for our property names. We added our person name, given, middle, and surname. We added their types, fresh out of NIEM. This is just cut and pasted out of NIEM. What kind of type is person? Well, I ask NIEM, I go look in any of the tools or the schemas. It's a person type. I'm not making anything new, so I don't care about a base type right now. Base types are mainly for when I'm making something new. The contained in. Well, now I filled in some stuff in the contained in. So this column again is for what contains this object. What does this object go inside of? And if I do a good job filling in this column and column J, then I can run code against this to do some fun things. But it is an extra burden while you're making the mapping spreadsheet. So if you don't want this column, and you don't want column J, which you're going to find more about in the next section, You don't need them. That's perfectly fine. You don't need to use them. I find them useful, so I use them, but you don't have to. It's your mapping spreadsheet. Person, well, I don't know what person is going to go into yet. I'm just working on this person object, so I'll leave that blank. Person name goes inside a person, and person given name goes inside a person name, and middle name goes inside a person name, and surname goes inside a person name. This is essentially a link back to what it goes inside of. No categories yet. Definitions are copied straight out of NIEM, no more, no less. Cardinality is the same as it is in the UML. You'll notice the 0 to many for the middle name. The line we added, the person name, we had to pick a cardinality for that, and it made sense to do 1-to-1, where this person's going to have just one name. You might have contexts and exchanges where they can have more than one name, and there are aliases in NIEM, there are alternate names, there are nicknames, there are preferred names. There's lots of ways to do names in NIEM. Which one do you use and how many do you have? That's a question for your subject matter experts. That's part of what you figure out when you're doing your requirements analysis before you even get to the mapping. And then here's the exchange path. And now you can kind of see what I'm talking about with an exchange path. It's the person. It's just the person object. What it goes inside of it, I don't know yet. But I do know you got a person name, and that person name goes inside of a person, so the path reflects that. And I do know that the person given name goes inside the person name, which goes inside the person. And so the path reflects that as well. Person/person name/person given name. And I'm going to keep track of this column. I'm going to keep this column populated as we go. And this column will reflect the structure just like the text document does. If you find that this is enough and you don't need the text document, then don't do the text document. If you find the text document is enough and you don't want to do the exchange paths, don't do the exchange paths. Again, it's your mapping spreadsheet, your development process. You can do it the way you like. This is my way though, so I'm going to do it my way. So that gets us to our next topic. That gets us to substitution groups. So you can see the person there. We crossed off person because we mapped that. We crossed off the name pieces because we mapped those. Now we're going to do birth date. So that seems real simple, right? It seems really simple. Let's go look in the SSGT. Let's go look. Here's the SSGT. Person's already open. Let's open it up. And there's person birth date right there. Yeah, that's cool, right? That's just going to hold a date, a string for the date, right? Oh, no, it's not. No. If you open it up, you find out that it's actually a complex structure with things inside of it. And one of those things is something called a date representation. And if you open that, you see a bunch of different ways to represent a date. What is that all about? Well, let's go back to the notes because some concepts can be represented in multiple ways. So one example are text or code tables. So you may have a code table for eye color, and one of the colors is blue, BLU. That's the code, and it actually is all caps, BLU. That's the code for blue. The color blue is an eye color in the eye color table. But what if you don't want it to be BLU? What if you want something that isn't in the code table? What if you want it faded blue like your favorite pair of old jeans? That's the color you want to do. And that's what color my eyes are. So I don't want to just say BLU. That doesn't really capture it because some people have steely blue eyes and I have pale blue eyes. So why don't we say pale blue eyes? Well, we don't have a code table with pale blue eyes, so why don't we use the string pale blue eyes instead? So you'll see that all the time in NIEM where there are code tables, but there's also a string representation. Two different ways to represent the same concept. A date is another one. A date can be a date, like a year, month, and day. It could be a date time, year, month, and day, along with a time code, 6 a.m., what have you. It could be a range with a starting date and an ending date. So how do you handle that? Do you have a bunch of different date objects? And then you've got the concept spread over a bunch of different objects. What NIEM does is has a single concept, so there's an element to represent the concept itself. And then there are multiple elements to represent different ways to represent that concept. So here are some examples. Birth date is a really good example because that's the one we're going to use. We just looked at it in the SSGT and we saw that it was more complex than at first we thought. So a person birth date contains a date representation. Whoops. There we go. Birth date contains a date representation. That date representation is represented, that date representation represents the concept of a date. And then we have things called substitution groups that replace it. So date representation is a substitution group head. Now when you see heads in NIEM, they follow one of two forms, either something representation or something abstract. They both mean the same thing. They mean this element is going to represent a concept, but not a particular representation of that concept. Instead, it'll be replaced by a particular representation of that concept. So let's look at the schema for this. Here's person birth date, and it is of date type. And this is right out of the NIEM schemas. Person birth date, it's of date type. But don't be fooled into thinking things of date type just hold a date string. They don't. Here's what date type looks like. Here's our date type. It's based on object type. So again, it's an empty container. And then it has four things in it. It has a date representation. Now we know now that that means this is going to represent the concept of a date, and there will be different ways of representing the concept that get replaced for it. Also has a date accuracy abstract, which is the same thing, only in terms of date accuracy. It's got a date margin of error duration, and then it's got a date augmentation point. You don't know what augmentation points are, but you will. We'll get to those. So what is date representation? Well, let's scroll down and look at it. So here's date representation. There's the element name. It's got this thing that says abstract equals true. Instead of type equals in some type, it says abstract equals true. What this means is that this element has no type. It doesn't have a type. And what that means is this element can't hold anything. Because how do we know what it can hold? Well, what you are defines what you can hold. And what you are is defined by your type. And there's no type. So we don't know. It can't actually hold anything. So what do we do with it? Well, we replace it. We replace it with something that can hold stuff. So here's where we get to substitution groups. Here's one of the choices. It's the date element, just date. It's of type date. This is a date string. This is a year dash month dash dd, day date. It's ISO it's an ISO formatted full date. And then it has an attribute we haven't seen yet, a substitution group attribute. And what's the value? That date representation object that's right up here. So what the substitution group attribute says is, anytime you see one of these, you can replace it with the date. You can take that out, you take the date representation out, it gets replaced with the date. Or any of the other options, and we'll go back and look at those options in a second. So in the instance document, it looks like this. Got our person and a person birth date, but the person birth date does not hold the string representing the date. It holds a date representation. But the date representation can't show up here in this instance document because it's abstract. It doesn't have a type. Instead, it gets replaced by something that has it as a substitution group head, in this case, date. So we have person birth date, then the date object, and then the actual string that represents a date. And again, this one is an ISO format, so it's year-month-day. The rest is the same. The rest is the person name we already saw. Now, one thing you may ask yourself is, if I do NIEM long enough, will I ever stop forgetting that things of blah, blah, blah date actually have a date object inside of them rather than a string? The answer is, I've been doing this over 15 years and I still make this mistake on a regular basis. And I just go ahead and put a date string in person birth date, and then I get an error when I try to validate it, and then I go, oh, that's right, there's a date object inside. And I should know better, but it's just a hard thing to remember. But a good XML editor will tell you when you've screwed up. So, you know, the XML editors have your back on this. If I'm doing this in JSON instead, it looks very similar. It is person object, it's a person date inside, and a date inside of there, and then the string for the date. Simple and easy. If we go look at the SSGT again, we can see all our choices for a date. We have a lot of different choices. We have a month date, which is just it's just the month. So, you know, like April. We have a date time, which is a date time string. So that is year-month-day. The letter T and then hours, minutes, and seconds, including thousandths of a second. So it's seconds dot, and then up to 4 digits. Again, that's ISO format. There are ones that's just a year and a date. There's a day and a day date that's just a day. There's a date range. If you open that up, you'll see it has a beginning and an ending date, start date, and an end date. There's a fiscal year date. There's a quarter ID. There's the date we've been looking at, just year, month, day. There's a year, month, date, and a Zulu date time. Some of these are Gregorian. The ones that start with G. So this is a Gregorian day date. So it's a lot of different options, and however you want to spin it, given these choices. Now, if we go over to Wayfair, Wayfair does it a little bit differently. So let's go in Wayfair, and let's go look at person birth date. Now, you notice the SSGT showed you the date representation and then had you open that to then show the different things that can replace it. Wayfair does it a little differently. Wayfair actually does a replacement for you when Wayfair shows the person birth date. So if you go and look at person birth date, it'll tell you right off it contains a date or a date range or a date time or a day date. It tells you in each case that it is replacing date representation. But Wayfair likes to show you exactly what this element can contain rather than showing you the substitution group head and having you open it. It's just a different way of looking at the same data. Again, this is the whole idea with multiple tools. You got multiple tools, they do things in slightly different ways. Use the ones that work best for you. Personally, I use both. Even though I wrote one of them, I use the SSGT when I'm exploring structure and how things fit together. I use Wayfair when I want to know everything about an element. And I always have them both up when I'm doing NIEM work because I use them both extensively. And you probably should too. I think you should as well. But here's how you see it in Wayfair. It does the substitution for you right here. So what we get in terms of artifacts is, well, let's look at the text. So here's the text file we've been working on. And you can see we just added person birth date and we added the date to it. So that's all we've added here in terms of structure. But that's nice. It's shaping up. We see we have a person and a couple things inside. We're seeing how the structure starts to fit together. Let's go look at the mapping spreadsheet. So here's the mapping spreadsheet we have going so far. So now you see I've added more stuff in blue. Now on the left here, we just had one line. We just had birth date because we were thinking, hey, person has a birth date and the birth date is this string. That's all there is to it. But that's not how it is in NIEM because NIEM wants to give you the ability to represent dates in different ways. So not only do we have person birth date, but now we know things of date type are not strings. Rather, they're an object that contains a date representation. And that in turn holds the date. And that date is of XML schema's date, which is an ISO formatted year, month, day type of date. We filled in more on the contained in and subgroup head columns. So for the, we said now we're saying the person birth date goes inside a person, and the representation, the date representation goes inside the birth date. The actual date element, though, is a substitution group, goes in, replaces the date representation. So I put that in a separate column so I can keep them straight, which ones are contained in and which ones are substitution group substitutions, essentially. Got all the definitions. We did cardinality. Note there's no cardinality on date. Each time you do a replacement, you replace one of the abstract elements. So the cardinality for the date object is actually based on the cardinality of the date representation. If I wanted to have up to 3 dates, I'd have to have up to 3 date representations, and each date representation gets substituted for. So there's no actual cardinality for the date. It takes on the cardinality of the date representation. And then we've updated the path. So here we've got person holds a person birth date. Here the person birth date has a date representation inside of it. Now because it's abstract and is going to be replaced by the date object, I put it in square brackets. And this is purely and solely my personal way of noting this. I like to note in my path that there is a date representation object there. It just isn't actually going to appear there in an instance document. It's going to be replaced with the date object instead. So that's just a note. That's for me. That's my format. Again, you can do your exchange paths how you want, or you don't have to do them at all. It's your mapping spreadsheet. You can do it how you want. So before we move on now, we need to have a quick conversation about namespaces, because now we're going to start using things that aren't in NIEM core. We're going to start looking at crash, and crash is injustice. So we need to understand a little bit about what we're talking about. So right here we'll see these guys have different prefixes. Crash has the J, NIEM core activity date has an NC representing NIEM core. These are nicknames referring to different namespaces. So what are namespaces? Namespaces are an organization layer in XML and in a lot of other fields too. Namespaces are a very, very common concept. But in XML, they're used to organize your elements by context, to take elements that may have the same name but different meanings and organize them into different namespaces. It's just another level of organization. The namespace gets identified by a prefix, and that prefix is just a nickname. It's a nickname for the namespace. We're going to see the full namespace as soon as I scroll down, the full name for one, and you'll see they're long, so they need a nickname to make it easier to refer to them. And NIEM governance is actually organized along these lines. We have the NBAC that governs NIEM core, and then we have other domain stewards that do the different domains, and these domain stewards are organized around the namespaces. Everything's organized this way. So the idea about needing namespaces is that the meaning of a word varies depending on its context. Take something really simple like the word case. Seems straightforward. Well, what kind of case are you talking about? Are you talking about a court case in a court of law? That's one kind of case. Are you talking about a valise, a case that holds stuff, a small piece of luggage, like a briefcase or a suitcase? You know, those are cases too. What about a case of soda or a case of beer? That's another use of case. What about something Sherlock Holmes solves, like the case of the speckled band? I won't spoil that for you, but it's the case of the speckled band. It's something Sherlock Holmes solves. Or in a medical context, you have a case of a disease, you have a case of the flu, or nowadays you have a case of COVID. And that's another context. And there are even more cases used in playing cards. I forget which card game, but it's like maybe gin. I don't know. I don't play cards, so. But there is case as a concept in there. Case as a concept in construction, like casement windows in your basement. So there are a lot of different contexts for case. So which case are we talking about? Depends on the context. And we do the same thing in NIEM by using namespaces to organize things into different namespaces in different schema documents. So here's what they look like. This is just the start of a schema. This is the start of the extension schema that we're going to be building close to the end as we make, this is where all our new stuff goes. There's a lot of stuff in NIEM, but you're going to need to add some stuff too, and we'll see examples of that as we go through the mapping. But right now, just know that here's the start of a schema. It's just the start. It's got a target namespace. This is the name of the namespace that is being created by this schema. And this is the name. Whoops, this is the name. This is what, let me try to get that right for you. This is the name of the namespace. Its name really is http://training.niem.gov/crashdriver/1.0/extension. That's its full name. My full name is Thomas Charles Carlson. Nobody calls me Thomas Charles Carlson. It's a mouthful. Everybody could say, oh, there's Thomas Charles Carlson. Nobody does. They just say Tom. They use my nickname. And we do the same thing in NIEM. You could, if you wanted, every time you wanted to refer to a namespace, use its full name. You could do that. Every element could have an attribute inside saying, here's my namespace. And I've seen it done, and it's really awful. Nobody likes to use full names. So instead, we give them nicknames. So here's that same full name. CrashDriver 1.0/extension has a nickname. Its nickname is EXT. We're just going to call it EXT. And we're going to stick that on the front of elements that are in that namespace for that full name. This is the full name for the justice domain. It really is http://release.niem.gov/name/domain/jxem-7.0/. The trailing slash is important. It needs to be there. That's its full name. But we don't want to call it that. We don't want to call it that all the time. That's a mouthful. So we're just going to call it J. That's its nickname, J. You see J:, you know that's the justice namespace, and it has this full name. And similarly, here's NIEM core. Here's NIEM core's full name. http://release.niem.gov/niem/core/5.0/. That's its full name. We don't want to call it by its full name. We're just going to call it NC. We're going to give it the nickname NC. So there, we've got three namespaces that we're defining. One is the one we're making, That's the target namespace. The other two are different schema files that will have the rules for those particular namespaces. So how will this extension document, if it's being read by an XML validator, know what those rules are in the other schemas? Well, that's where the import statement comes in. So the import statement maps namespace names to locations of the actual schema documents. So here's a namespace. This is the full name. Does that look familiar? I'm not going to read it off again, I swear. Does this look familiar? It's the same name up here. It's the full name of the justice domain. So every time a validator sees the J prefix, they know, oh, that actually means that full name, and that full name, the rules for that are in this schema here. The import statement maps the namespace to the schema that represents that namespace, and so a validator can get the rules there. Same thing for NIEM core. Here's the full name for NIEM core. This is where the schema is that has the rules for NIEM core, that defines everything in NIEM core. One thing to be careful of, if you decide to do XML in XML Spy on Windows, which is a perfectly fine thing to do, but XML Spy has a tendency to default to making these backslashes, because that's how Windows does paths. Right? Windows does backslashes to designate different directories. That's just how Windows does it. Other systems use forward slashes. Unix systems use forward slashes. That includes all the Linux servers out there. That includes Macintoshes. It includes a surprising large percent of the world that might consume your XML. Even though most everybody has Windows desktops, especially in a work context, that is not true of servers. That is not true of the computers that are consume the XML. Now the nice thing is if you do forward slashes, that will work on everything including Windows. Windows will make the translation to backslashes. When you try to consume XML on a Windows system, it will automatically change those to backslashes. But the converse isn't true. Unix systems will not change the backslashes to forward slashes. They won't do it. So for compatibility on all platforms, make sure that schema location paths are forward slashes. It's just a default setting in XML schema. But if you get it wrong and you use backslashes, your XML is, a lot of systems are going to just choke on your XML. They're just not going to work. Now JSON-LD gives us a similar thing. It gives us a context attribute with an @ sign on the front. This marks it as a special JSON object. And the context is used to do mapping, to map these nicknames to the full name. And the idea here is this provides a link from JSON back to the XML, back to the NIEM namespaces themselves. So it does the same thing. Now it doesn't get processed in the same way it does in XML world, but this is a link back. This is a link that says if you see ext colon in front of a JSON term, it's talking about from training.niem.gov/crash driver blah blah blah. You do have to have the pound sign on the end. Don't know why. Same with J. You see a J crash? Well, that's this part of NIEM. It's a map back. Again, you need the little pound sign on the end. I don't know why. And same for NIEM core. It just maps NIEM core to the full name for NIEM. So that's what that's about. That's a context. It tells you what these little nicknames mean, what they link back to, and in this case, they link to NIEM objects. As mentioned earlier, NIEM doesn't have any support for JSON schema yet. Your JSON documents just mirror an XML document that would validate against the XML schema that's representing your exchange. That's not ideal. That situation is changing. We're working very hard on that. But right now, that's what you're doing. You got an XML instance and you just match it in your JSON, and that's how you do NIEM and JSON. It's not great, but it's where we are right now. But it will get better. It will get better within the year. And no matter when you're watching this, within the year, it'll get better soon. But that's namespaces in a nutshell, and that gets us to inherited properties. So inherited properties, well, let's look at our UML, see where we are. Crossed off birth date, whole person object is mapped, that's good. Now we're gonna look at crash. So we got a crash item, and we have a crash date. So we need to go find crash date. And that's actually harder than you might think. Let's go do it first and then come back. So let's go look at the SSGT, kick that off. Look at Wayfair, kick that off. Wayfair came back right away and said no results. There's nothing. There's nothing in NIEM with the name crash date. How could that be? Well, let's look at the SSGT since that's always right. The SSGT didn't find anything either. What's going on? Certainly we must have a crash date in NIEM, right? If there's not a date for a crash, we've done something really wrong. Has to be a date for a crash. Well, let's do a little exploration and see what's going on there. So let's just look for crash itself. Do the same thing in Wayfair. And we'll just get us right to crash. Okay, so let's look at the SSGT first. Here's our crash. And we love SSGT because we can look at this stuff right in the search results. Let's open it up. And I don't see crash date anywhere there. There's no crash date. There is no crash date. Oh, what's this up here though? Crashes of crash type. Show inheritance. Let's click on that. Oh. Well, now we can see the crash type is based on some things. Crash type is based on driving incident. Crash is a specialization of driving incident. It's a special kind of driving incident, one where there was a crash. And driving incident is derived from incident type. Incident type is a generic incident. A driving incident is a special version of it. An incident type is derived from activity type, which is a general type of activity. So you got activity type is very general. Incident type is more specific. Driving incident, see, we've crossed domains now. We've gone from NIEM core to justice. Driving incident is a special kind of incident, and crash is a special kind of driving incident. And crash inherits from all three of these types. Anything any of these three types have, crash type inherits because it's a special version of them. So to find crash date, we better go start looking through them. Well, let's look through driving incident first. And we eyeball it. If we don't see any driving incident date there. Okay, well, let's go back one level, up one level. Let's look at incident type. Anyway, incident event, observation text. I don't see a date. Okay, well, let's look at activity type. There we go. There's activity date. And just like birth date, activity date has a date representation inside. And that date representation has all the different forms of a date we can use. So, now we see. Crash date is represented by an activity date in the context of a crash. If I see activity date inside of a crash, I know that's conceptually a crash date, even though it's not called crash date. Let's look at Wayfair. So here's crash in Wayfair. Again, I don't see crash date over there on the right. But when we get to the fold, when we get below the fold here, we see on the right everything crash can contain. Everything it can contain. This is going to bring the inheritance in. So here's the stuff it gets because it's crash type. If we scroll down, we're going to see driving incident type. Via driving incident. So it inherits all these. If we keep going, also inherits from incident type. We don't see date there. Finally, we get to activity type, and there's the activity date right here. So we found it there too. It's just several levels of inheritance deep. So you have to go and look at all these different levels to see where it is. Now, sometimes there is a contextual search in advanced, and sometimes it works and sometimes it doesn't. I'm going to take a chance and try it. Search context definitions. And it didn't seem to do anything. Yeah, it didn't do anything. So I was worried that wouldn't work. It used to work, it doesn't now. Right now there is no way to kind of search for crash date and get the answer. We're working on it. We've got some plans that may change in the future. But for right now, you need to know these things. Again, you cannot do just one-to-one element mapping with NIEM. You have to understand crash. You have to understand the different types that crash type is based on. You need to understand how these things fit together to understand how it all works. Let's go back to the notes and take a look. So, some concepts don't exist as elements using the term for the concept. Right? There is no crash date in so many words. There is no crash date. But there is an activity date which can be inside a crash object. And that provides the context that this is a crash date. That's how NIEM does it. Let's look at the schemas for it so we know what the schemas look like. Here's our crash element. It's of crash type. So if we want to know what crash can hold, we have to go look at crash type. Here's crash type. Again, I've removed a bunch for clarity, but it's based on driving incident type. It extends it. It adds additional things to driving incident type, but it inherits everything in driving incident type. So here are the things it adds. It adds a crash service call, crash information source, a few more things. But let's go look at driving incident. All right, here's driving incident type. Right here, it adds some severity abstract, a commercial vehicle abstract, some other things, but no date. But it's based on incident type. So we go look at incident type schema. Here's incident type. It has events and jurisdictional organizations, but it doesn't have an incident date, but it's of activity type. So we have to look at activity type. Here's activity type, and there it is finally, activity date. So if you need a crash date, it's activity date inside a crash object. If you need a driving incident date, it's activity date inside a driving incident object. If you need an incident date, it's activity date inside of an incident object. All of these things inherit from activity date or activity type and thus inherit the activity date. When we look at the actual instance document, then it just looks like this. Got a crash object, got an activity date object, and then of course inside there we have the date in our ISO format. Note that at no time does this actually get called crash date. It's activity date in the context of a crash. Now that seems kind of onerous, but if we added a separate date for each and every element, we'd have thousands of them, and they'd all be exactly the same. They're all conceptually the date an activity occurred. So NIEM essentially makes this object-oriented. This maps very closely to things like RDF. If you're into RDF and things like that, this matches closely to how those things work. This isn't a flat data dictionary. This is a data model. And crashes of crash type, which inherits from a bunch of more generic types, and that's where it gets its date. And again, there's no reason to have a crash date. That's just replication. Activity date's already there. And in the context of a crash means the same thing. The JSON looks just the same. Crash, activity date, date, and then the actual string for the date. Now you need to know about this stuff. Okay? You need to understand this concept. You need to know these cases are out there because they are all over. Now, are they this deep usually? They are not usually this deep in NIEM. Usually things don't go more than 1, maybe 2 levels deep. This one is 4 levels deep. It's one of the deepest things in NIEM. It's part of the reason why I chose it for this class, is it shows these inheritance levels. Another one is commercial vehicle, because it's a special kind of vehicle, which is a special kind of conveyance, which is a special kind of item. And that goes several levels deep too. So if you want the color of a car, well, you can go back and look at item color. It's going to inherit a whole bunch of things. So this is very common in NIEM. You need to know about it, but you don't need to jump your way through the schemas each time. Remember, we have tools. Okay, you can do it. You can do it in the SSGT, which is sitting here kind of in a hold mode at the moment. There's so much going on behind the scenes with the SSGT to provide this functionality that you can open things that just sometimes it just gets a little lost. But you can view it here. You can view it right here in the SSGT by opening up crash type after you do the show inheritance, and you can get it in Wayfair. Wayfair does it automatically. You just have to scroll down below the fold into the bottom quadrants, and that southeast quadrant will show you everything that the item contains, taking the inheritance into account. So use the tools for this, but again, underscore, you need to understand. You need to understand that JCrash is an object that inherits from all these different types and need to know to go look in those different types. Really important. These aren't one-to-one element matching. We are matching objects in UML to objects in NIEM, and it's not a trivial one-to-one matching, so you need to understand the objects. Artifact-wise, here's what the text looks like. We've added a crash, we've added an activity date, and we've added a date. So we've added basically another peer level object. Here we have this person object just kind of floating out there. We don't know what it goes in yet. We have crash. Another little peer little object just sitting out there. They're not inside of each other. They're at the same level. And we have an updated mapping spreadsheet. So we'll pull that up. So here we've added the crash stuff. We've mapped it to jcrash. We know that the date now is mapped to activity date. But again, we had to understand how crash was set up to know that. We couldn't just search for crash date and expect that to work. And we also know now that dates have date representations inside, and the date representation has the date format. And we know by now this is ISO format. This is year, month, day. Now you might be asking yourself, I mentioned it several times now that it's ISO format. What if you don't want to do ISO format? Well, that's okay. You can make your own format however you want. You want it just to be a string? Fine. XML schema supports patterns, so you could define a string with a certain pattern. So if you want day, month, and year, or you want month, day, and year, or you want whatever, you can define your own. And what's really cool is when you make your own date element, all you have to do is give it a substitution group head of date representation. And suddenly everything in NIEM, almost like magic, can include your format inside an activity date or a birth date or any of the dates. Anything of date type can now contain your new date because you made it substitutable for date representation. That's the magic of substitution groups. You don't have to make a new activity date object. You don't have to make a new birth date object. You just have to make the new object and give it the right substitution group head. Are contained in now. Okay, so the crash date is contained in a crash. No, it's not crash date, right? It's activity date in the context of a crash. And then that date representation is inside activity date, and the actual date is inside date representation. We've got all our definitions, we've got our cardinality, and we've got a whole separate set of paths. We've got a jcrash with the activity date, Tom's funky notation of putting square brackets around the group head, and then the date replacing that. And so we've got that whole mapping. And that gets us through the three major topics. Before we move on, this is a really good place to take a breath and decide whether you're feeling good about what you've seen so far. Because you've seen the three major topics. If you're hanging with this so far, and if this makes some sense and you're understanding this, you're in really, really good shape for the rest of the materials. The rest of the materials are all spins on the three basic things we've looked at. Elements have types, and the types define what they have. Substitution groups are used to provide a single element to represent a concept, which then gets replaced by multiple representations of that concept. And elements inherit from the types their type is derived from. So if I'm an element of a certain type, and that type is derived from a second type, I inherit from that second type as well. If you understand those three concepts, you understand the basics. You understand the basics of XML schema and the basics of how NIEM works. None of this stuff has been NIEM specific. These are standard XML things, standard XML schema technologies and concepts. And if you understand them, you're in good shape. If you don't understand them, you should probably at this point go back and review the materials, or email me a question, or send a question to the Contact Us form on NIEM.gov. If you don't understand these three concepts, you really want to get them down before you go further, because everything else is going to be built on these three concepts, and you really, really want to know them before we move on to linking things together.